What's good, y'all? Here's another Batana video covering the BGCSE math. This time we'll be talking about basic graphing, and we'll be talking about a question that I pulled directly from a paper 2. So typically on a paper 2, there's always some question on graphing, and they're pretty much always set up the exact same way. So let's just jump right into it. So in part A of this question, it says to copy and complete the following table for the graph of y is equal to negative 2x minus 4. So here they give us a table of values. Let me just erase that. They give us a table of values. So this table of values has x values and has y values. So what does that mean, right? Basically what that means is if you look at a graph where we have the y-axis, we have the x-axis, each of these points on this table correspond to a point on the graph. So for example, the first point given negative 4 and 4. So what this means is on the x-axis, we're going to go to the negative 4 position. And on the y-axis, we're going to go up to 4. And then that's where our point is going to be. So we basically do that for all of our points on this graph. So what they want us to do is they want us, before we even graph this, they want us to be able to complete this table. So to complete this table, we're going to be utilizing the formula for the graph that they gave us here, where they said y is equal to negative 2x minus 4. So what we do here, and I separated it into parts where, we have the two missing values for y. We have it in part 1 and we have it in part 2. So the way that we do this is we just rewrite the equation and we plug in values for x. So how do we do that? So I'm just going to take the formula. So y is equal to negative 2x minus 4. So y is equal to negative 2x minus 4. And essentially what we do is we look at the x value in that specific column. So we look at this column. So we look at the x value, and all we have to do from there is just plug in the x value to where we see x in our equation. So for part 1, we have y is equal to negative 2. And then our x value here is going to be negative 2 minus 4. So you can just calculate this using a calculator, or you can do it with your head. So here we just get y is equal to, and we have negative 2 times negative 2. That's just going to give us a positive 4, because a negative and a negative give us a positive. And then we're just going to say minus 4. So 4 minus 4 is of course 0. So y is equal to 0. So here where I have that 1, we're going to now just put down sub 0. So let's do part 2. So same setup. So with part 2, what we're going to do is we're going to say y is equal to negative 2x minus 4. That's the formula for our graph. So again, we're looking at this column here. So that means that we're looking at this x value here, right? So we're just looking at this x value here. So we're just going to substitute that into the equation. So we get y is equal to negative 2. We substitute 2 in. And then we say minus 4. So once we evaluate this, we just get y is equal to, so you have negative 2 times positive 2. That gives us a negative 4 minus 4. And then when we evaluate that, negative 4 minus 4 is of course going to be negative 8. So that's how we complete the table that they gave us. So I can just, where I have the 2 here, where I have the part 2, I can just now put in negative 8. So this is essentially what they want you to enter for these questions. They want you to redraw the entire table, and then from there, they want you to then put in the correct answers using the formula for the graph that they gave you. And that's how you solve part A. So now let's go on to part B. So it says using a scale of 1 centimeter to 1 unit for values of x from negative 6 to 4 and values of y from negative 8 to 8, they want us to draw the line graph. They want us to draw the line of y is equal to negative 2x minus 4. So that's a mouthful, right? But the biggest takeaways we need to take away from this is we have to, and I'll write them on the side here. So the main things that we need to do is we need to show our scale. Then we need to label our axes. So that's going to be our x and y. And then we also need to label plot and label the line. So those are the three main things that you should get out of that question. So they're basically saying that, we want to use a scale of 1 centimeter to 1 unit. And then we also want to use x values from negative 6 to 4. And then we want to use y values from negative 8 to 8 in order to draw the line for the graph y is equal to negative 2x minus 4. So I've already prepared for us a graph that illustrates what this would look like. So if we look at it, let me just zoom out. So if we look at it, and typically they give you graph paper on the exam, but if we look at it, we have our scale shown here. We have our y-axis and our x-axis properly labeled. And as they told us in the question, our y goes from negative 8 to positive 8. Now I can see here I made a mistake and I actually didn't label these as negative. So I can just go back and do that. So it's very easy to make mistakes on this. So it's good for you to, ensure that you always cross-check your work. So now that we have this, now that we have our graph set up, so we already showed our scale, we labeled our axes. So now it's time to plot and label the line. So for us to plot and label the line, and remember we're using the line y is equal to negative 2x minus 4, what we should do to plot this is we should just use this table of values here that we already have, right? Because this is going to make it much easier for us. So what I'm going to do is I'm just going to copy this over. We're going to bring it over here for us to use. All right. So now that we've copied our table of values over, we can essentially just plug everything in. So just like how we did it in the beginning of this video, all we need to do is we need to look at our x values. So we're going to first look at this column, and we're going to just continue plotting all the other columns until we're done. And then that should give us the graph of y is equal to negative 2x minus 4. Right, so that's negative 2x minus 4. So let's go to the point. So we're just going to start off with this column here. So whenever you're graphing, you want to start off with your x value, and then you want to go up to your y value, just to keep it simple. So we're going to go across 4 spaces on the x-axis. So this is going to be our 4, negative 4. And then we're going to go to the point, then we're going to go up on the y-axis 4 units. So that's going to be our first point there. So on the x-axis, we went to negative 4, and on the y-axis, we went to positive 4. So let's do our second column. So again, same process, you start with the x and you go to the y. So here, we're starting at the point negative 2x, right? So we're going to go over negative 2, and we're going to go up 0. And of course, if you're going up 0, that means you're not really going up. So that means this is going to be our second point. So let's move on to the third column. The third column says we go to the point x is equal to 0, and then we need to go down 4 spaces. So whenever you see a negative, that means, you're going down for the y, or if you're in the x direction, you go into the left. So we're just gonna plot 0, -4. And now we're gonna complete our final column where we start at the point x is equal to 2 and we go down to -8. So x is equal to 2, and then we're gonna go all the way down to -8. And once we have all 4 of our points, all we need to do now is just draw a line between them. So I'm gonna just pull out a ruler right quick. So we're just gonna draw this line. So the way I make sure that my line is properly drawn is I just look at the two ends. So all I'm looking at, the only thing my eyes are on right now is this point and that point. As long as I can get my ruler on those two, then we know we good. So I mean, that should be good enough for right now. But on the exam, you want to get this as accurate as possible. So yeah, we're gonna go with this. Yeah. So that's gonna be our graph. And now the final step to this is you just need to label your graph. So they want us to graph the line. I'm going to go back to the question. Draw the graph of the line y is equal to -2x minus 4. So right next to it, it could be anywhere next to the line. But right next to it, I'm just going to write y is equal to -2x minus 4. So that, people can know that this is the line that I was graphing. So now it goes on to say, calculate the gradient. This is part C. Calculate the gradient of your graph in B. So when we look at gradient, right, and I'll show you guys from the graph. When we look at gradient, what we're really looking at is the slope of the graph, like how steep it is. So if you look at this example over here, let's look at this example over here. So let's just say I have this graph, right? Let's just say that, it goes kind of like that, right? I know that this graph is going to be much less steep than maybe something like this, right? Excuse my bad drawing, but that's what we're looking at. We're looking at the steepness. So we're looking at how steep is this. So you could think of it almost like a hill. If you look at it like a triangle, you could think of it like, okay, this is a much steeper triangle than this is, right? So that's what we're really calculating when we're talking about the gradient. So in order to calculate that, we have a simple formula that we can use in order to calculate that. And I will just write it down here. So the formula that we have is y minus y1 over x minus x1. And then we say m is equal to that. So m is the same thing as our gradient. So I'll just write here m gradient. And this symbol right here is just saying that m is defined as the gradient. So that's just me saying that m means gradient. So what this means is that we need to take 2 points on the graph and then use those 2 points to then plug them into this equation to get our slope. So that means that we need a y and we need an x, and then we need a y1 and an x1, right? So here order doesn't really matter. So that means I need to find 2 points. So y, x, and y1, x1. So let's go to the graph and let's see if we can find 2 points. So from the graph, there's a few easy points that we could use, right? I mean, we could use any points, any of these points, but there's a few easy ones that we can use, and they are typically the ones that involve a 0, right? So the 2 points that I'm looking at are this point and this point, right? And you'll see why I say that when we calculate it. So if we look at this point, we'll take this point to be x. So we'll say for x, y, we have x, y. So our x in this case is going to be -2, and our y is going to be 0, right? For that point. And then for this point, we have our x1 and our y1. So x1, y1. So our x1 in this case is going to be 0, and our y1 in this case is going to be -4, right? So if those are our 2 points, all we need to do now is just substitute those into the equation. So we had, and I'll just put it just like this. So remember, the equation is y minus y1 over x minus x1. So rise over run. That's the way to remember it. So we just say rise over run, right? So what we're gonna get from this equation now, we're gonna get m is equal to r. So we said we had the points. I'll just rewrite it here so we can kind of see it. So we said we had the points. So we said that we had the points x, y, which was -2 and 0. Then we had the points x1, y1, which is equal to 0, -4. So now when we plug this in, we can just, wherever we see y, so we have the y's line up like that, and the x lines up like that, right? So I know that my y is going to be 0. So we're just going to have 0 minus, and then the same thing here. We have our y1 is -4, and our x1 is 0, right? So we have to make sure that with this, -4, that we put the -4 in there. So we have our y is equal to 0, and then our y1 is equal to -4. And we're going to divide that by our x, which is -4, subtracted by 0, right? And here, once we evaluate this, we get 0, and we have a negative and a negative. So a negative multiplied by a negative is going to be a positive. So that means we get +4, and then we get -4 minus 0, which is just -4. Oh, my bad. That's supposed to be a 2. That's supposed to be a 2 because here we had -2, and then here we had 0. So that's supposed to be -2 minus 0. So that means that -2 minus 0 is just going to be -2. So from here, we can just, you just can divide this. So you have 4 divided by -2. So it's a positive number divided by a negative number. That gives you a negative number. So we get 4 divided by -2, which is just going to be -2. So that is going to be our gradient. So every time whenever they tell you to calculate a gradient, they mean that they want you to go through this process. Now, the way that you can check this in 2 ways, right? The first way is by going to the graph, right? And looking at the slope for yourself. So if we look at the slope, we can confirm that this is actually equal to -2. So for every 1 So if we look at this one more time, I'm gonna show you all something. So remember I said that m is equal to rise over run, right? So if I say that m is equal to -2, that's the same thing as saying m is equal to -2 over 1. Because any number divided by 1 is just going to be the same number again, right? So 1 divided by 1 is 1, 2 divided by 1 is 2, right? And so on and so forth. So that means that for every time that we go across in the y direction one time, that means that we need to go up. That means that we need to go down, sorry. That means that we need to go down in the y direction 2 times since it's negative. So we just go back to this graph and we can prove that. So I'm gonna erase this stuff here. So let's prove that. So if we look at, let's look at this point here again, right? So if I go across 1 unit, and if I go down, see I went down 2 units, so I went 1, 2, right? Since I went down 2 units, then that shows you that the slope here is just going to be equal to 2 because it's rise over run. So it's going to be equal to -2, right? So it's rise over run. So I went down 2 for every time that I went over 1 time. And that's just one way for you to test it. And there are other ways as well, but we'll save that for another video. So that's part C. Our answer for part C is just going to be equal to -2, right? This is our answer right here. So let's move on to part D. So part D says another graph goes through the point 3, 5 and has a gradient of 1/2. Draw this graph on the same coordinate plane. So you say basically they give us the gradient and they give us the first point, right? So they want us to use that same thing that we just spoke about how the gradient works. They want us to use that to draw out an entire graph. So let's just get to it, right? So we say the point 3, 5 and a gradient of 1/2, right? So we're gonna draw this. So it goes through point 3, 5. I'm just gonna say, and this is just my scratch work, right? Let me just say the scratch. This is our scratch work over here. So the second graph goes through the point. So we'll say point 3, 5, right? And now we're going to say it has a gradient of 1/2. So how do we even begin to digest this, right? So firstly, the first thing that I would do is I would plot the point 3, 5, right? So remember, whenever we're plotting, the first number is the x value and the second number is the y value, right? So that means 3 corresponds to our x value. So that means we're going to go across 3, right? And then 5 corresponds to our y value. So we're going to go up 5 times, right? So that's the point that they're talking about right there, right? So I'm going to put this, let's put this in yellow. Why not? Let's put it in yellow. So that's our first point, right? So now where do we go from here? You know, they're saying the gradient is 1/2, but we know we can't be going this way, right? We need to go this way because for us to even stay on this graph, we need to go this way because we don't have that many units going this way. So let's continue to talk about this gradient, right? So remember, gradient is just going to be the rise over the run, right? So we have, that's our rise over run. So that means for every 1 unit that we go across, for every 2 units that we go across, that means we have to go up 1 unit, right? So let's just say if I went in the other direction, that means that if I go in the left direction 2 times, that means I need to go down 1 time. So it works in both ways, right? And I think a better way to illustrate this is we can just set up a sample graph right over here, right? So what this means is, let's just say I start at this point here, right? Or better yet, let's just say that I start at this point here, right? So all this means is that if I'm gonna if I'm gonna run across, let me put that over here. If I'm gonna run across 2 spaces, so let's count 1, 2, right? If I'm gonna run across 2 spaces, I need to go up 1 space. So that means that's gonna be my final point right there, right? And it works in the opposite way again. So that means in the same opposite direction, if I decide to go to the left 2 spaces, that means that I need to go down 1 space. So let's try that. So we go over 1, 2, and we go down here. And if you look at it, it lines up, right? So with the gradient, we can take the gradient in both directions. And that's what we're gonna do. That's what we're gonna do to plot the rest of this graph. So let's go back to the point 3,5, right? And I'll even label 3,5 just so we all on the same page. 3,5, right? 3,5. So what we're gonna do here is we're gonna go across in the x direction on the left. So that means that if we go across 2 times, we need to go down 1 time. And we're just gonna continue doing that until we run out of space. So that means I'm gonna go across 2, and now I'm gonna go down 1, right? And that's gonna be my final point right there. So let's do it again. We're gonna go across 2, so we're gonna go across 2 points, and now I'm gonna go down, so that's across. Now we're gonna just go down to 1 point, right? And if you look at it, things are lining up already, right? The 3 dots line up. So we're gonna keep doing this. So we're gonna go across 2, down 1, right? Now we're gonna do it again. Maybe this will be the last time. Across 2, down 1, and boom, we have a series of points that we can now plot, right? So again, I'm gonna whip out the ruler for y'all. See if we can get this right. So let's just align that. And again, just for technique, whenever you're doing this in on your exam, you just want to line up these 2 points, just like so. All right, cool. Bang. So, and this is gonna be the graph that they gave us. Now they didn't give us a label for this graph, so I'm just gonna call this. Let's see, what part of the question was that? Let's see. That was part D. So I'm just gonna label that part D. That's all we're gonna do. It's gonna say D, right? That's all that is. So now let's go to the final question. And the final question says, write down the coordinates of the point where the lines intersect. So when they say intersection, when they say the point where the lines intersect, that means that we're looking at the points where the lines cross, right? It's the same thing. Those words basically mean the same thing in this case, right? So we're looking at the point where these lines cross. And obviously, when you look at it, you can see that they both cross at this point right here, right? So we just need to write down the coordinates. And remember, whenever we write coordinates, we write the x value first and then the y value second. So you could use a line to trace it just in case you're not sure. So on the x-axis, we have -3. On the y-axis, we have 2. So that means they intersect at the point -3, 2. And that's going to be the answer for part E. So that's how you solve this question. I'm just going to show all the work here so y'all can go back and look at it. So yeah, that's how you solve this problem. I hope this video was helpful, and I hope that you now know how to do basic graphing for the BGCSE paper 2.